Hey everyone, welcome to another video. A different setup. So for now, let's get to the video part. Okay. Have you ever wondered how your router figures out to what device it has to forward what internet traffic? Let me put before you an example. Say we have one router and two devices that are connected to the internet through our router. If the user on device 1 visits the example.com in their browser and simultaneously the second user on the second device visits the videos.example.com in their browser, both users would be able to reach their respective websites and the data of both websites would reach the users as intended. But how exactly is that happening? Why didn't the data of videos.example.com accidentally reach user 1 and the data of example.com reach user 2, or the data of both websites got intertwined with one another? Because both devices have the private IP addresses issued by the router, and the private IP addresses, as the name suggests, are private. They can't be reached over the public internet. To reach the devices across the internet, we have a different set of IP addresses which we call the public IP addresses. These IP addresses are unique and they are assigned by the ISP whenever anyone connects to the internet. In our example's case, this public IP address is configured on the router. Whatever internet traffic that is reaching this router and your router as well in the real life, its final destination is this public IP address. From there, it is the router's sole responsibility that it distinguishes the packet of both websites from one another and forward it to their actual intended locations. So how does a router accomplish this? Does it maintain some list logging every domain the user on the local network are visiting to correctly route the global internet traffic back to the local network devices? It may, but that would pose a huge privacy risk. So if not maintaining the list, just how does a router manages the flow of internet traffic to your private devices? Enter NAT or network address translation, or to be more specific, NAPT, network address port translation. When we type in any website's URL in the browser, our browser or the OS retrieves that website's IP address from the DNS resolver. However, before we connect to the destination IP address, there's one more thing that gets automatically attached to this IP address, and that is a port number. If IP address, let's say, is the address of the building, then port numbers are room numbers of different businesses operating under the same roof. Port numbers allow us to host loads of different services on a single IP address. So when we connect to this or that website's IP address, we are connecting to that IP address on port 80, and if the connection is encrypted, port 443. There usually runs a server on these port numbers that processes the web traffic we typically send through our everyday browsers. Okay, when we establish a connection to this or that port number on this or that IP address, we call them the destination port numbers. Opposite to the destination port numbers are the source port numbers. These source port numbers get assigned to our side of IP addresses, whether they are public or private, by the router and the operating system. More on the OS later. Say in our example's case, our public IP address 203.0.113.2 is establishing a connection with example.com's IP address from the port 62,571. The source port numbers have one of the most crucial roles to play in NAT because they are utilized to differentiate internet sessions from one another. To explain, let's revisit our example. Say the user on device 1 presses enter to visit the videos.example.com in their browser, and the second user photos.example.com in their browser. The DNS resolves the IP address of both websites, but before our network traffic starts leaving towards its destination IP address, our router translates the private IP address of the source packets to its public IP address, because remember, the public IP addresses are globally routable. By translating our private IP address to public, the servers of both websites would be able to send their packets back to our router. Okay, this is the basic principle of NAT. Okay, it translates the it usually translates the private IP address of the device to a public IP address. It was first introduced in 1999 when the IPv4 addresses were depleting at ever increasing rate. deployed, and there was present a need to address the issue before IPv6 would eventually be get globally deployed. Okay, the NAPT is a type of NAT, as it not only translates the IP address, it also attaches a unique source port numbers to remember from which particular client the traffic is generating from within the private network. Okay, let's say in our examples case, NAPT attaches port number 62721 to the packets that are leaving to the internet from device 1 and 62741 to the packets of device 2. The router notes down these source port numbers in the NAT table. When the server of videos.example.com sends its packet back on port 62721 and the server of photos.example.com on port number 62741, the router checks if NAT states are active on these two particular port numbers. If they are active, like in our case, the router translates the public IP address of the packets to their original private IPs, and it then forwards the packets to their respective devices. And this is how, my dear people, the devices in our example case and your devices in real life as well, whether they are 2, 4, 10 or more, they all end up getting the intended internet traffic, and this is all thanks to the source port numbers. Okay, in this context, it is also easy to understand how port forwarding works. When you create a port forwarding rule, you are directing your router to create a static entry into its NAT table that whenever any traffic hit the port X on your public IP address, translate that public IP to the private IP address Y and forward the traffic to the client on the same port X or a new port Y. Okay, I hope this would help you in better understanding the role of port forwarding. Before closing this video, how does a router distinguishes that the packet coming from a device belongs to what session? Think about it. We often have multiple tabs of the same website opened in our browser. Since the domain name is the same, it is very likely that the domain name would also resolve to the same IP address, regardless of how many times we would open the same website in different tabs. To our router, all internet packets are leaving to a single IP address, and all the packets are returning from that same IP address. Since the source and the destination IP is the same, to our router it has had no need to use different source port numbers, yet all the videos in our example in all our tabs are playing smoothly. There aren't any glitches, there isn't a single instance where few frames of different videos are showing up in different streams. So how is this happening? Simply speaking, the answer again lies with the source ports. When you open your browser and visit any website, your browser asks its underlying OS to attach a unique source port number to the outgoing connection. Hence, if you are browsing to the same domain from 10 different tabs, all those connections to the same IP address would be leaving to your router with different source port numbers. Okay, since the source port numbers are different, the router is going to treat the packets all leaving to the same destination IP address belonging to different internet sessions. Okay, so this is how the packets of every video stream is able to travel on its own distinctive lane even when the underlying highway is the same. Okay, my dear people, so I believe this is sufficient for this video part. Yeah, I can take a breath. So before closing this video, I have achieved this setup with just a light which is called key light. Okay, I have just learned that, and a reflector, and there's a what it's called, I believe, hair light or rim light. So it's a good start, and it's a very it's a incredibly cheap setup. I believe this is a good start. If you want to know how I have achieved this setup, because if you are too starting on YouTube and you are on budget, you can ask me. By the time someone would ask for a tutorial, I would have make a lot of improvements to this setup. So I guess I'll have a one or few advices to give to you. Okay, so I believe I'll see you for now. I'll see you in the next one. Bye everyone.